Alright, the purpose of this video is going to be to go over problem set 5.6 while I'm away. So number one starts off with a reaction between lead 2 nitrate and potassium iodide. Both of these are aqueous. Okay. So our first step is to see what would happen if we double replaced. What happens if the positive ion from the one compound, the lead ion, the metal, goes with the negative ion from the other compound, and what happens if the same thing happens the other way? What happens if they swap partners? Okay. So if we kind of think about this, what we got here in lead is lead with a +2 charge, and then over here from the potassium iodide, we're bringing iodide to the party, and then going the other way here, a potassium ion is +1 charged, and nitrate ions are polyatomic, and they have a -1 charge. Okay, so when the lead ion goes with the iodide ion, it's going to take two iodide ions to go with one lead ion and make lead 2 iodide. So one lead and two iodines. And then looking up at potassium and nitrate, we can see that the potassium is a +1 charged ion and the nitrate is a -1 charged ion. So potassium nitrate is written like that. Okay. It is important that you write them in that order. We can't flip-flop, put iodine before lead or nitrate before potassium. Same rules we used when we learned naming. The positive ion has to always come first. Okay, the next thing that we should try to do here is balance this reaction, and it looks to me as though if I were to put a 2 in front of the potassium iodide and a 2 in front of the nitrate, that would be pretty good. Okay. Next thing we're going to do is we're going to use our solubility rules in order to determine what are the physical states of these compounds. So the lead 2 iodide, if I look at rule number 3, it says all salts of chloride, bromide, and iodide are soluble except those with blah blah lead 2. That means that this is going to be a solid. And I look at potassium nitrate, and there's two rules. Rule number 2 says it'll be aqueous, and also rule number 5 says that it'll be aqueous. So this is going to be soluble. It's going to be aqueous in solution. So we end up having to do the whole bunch of work here because we have got a precipitate in lead 2 iodide. So when we write the full ionic equation, we're going to take everything that's aqueous. Everything that's aqueous includes the lead 2 nitrate, the potassium iodide, and the potassium nitrate, and we write those as ions because what they really are is they're separate from each other as ions. So the lead 2 ion is separate from two different nitrate ions, and then we have the 2 potassiums because of the 2 in front there, and the 2 distributes through, and we have 2 iodides, and that gives us, we're going to write the lead 2 iodide as one thing because it's a solid, it stays stuck together, but the potassium nitrate is aqueous, which means that the ions are separate from each other. So there's our full ionic equation. We go through here and we pick out our spectator ions. The 2 potassiums don't do anything, and the 2 nitrates don't do anything. They're the same on both sides of the equation. They kind of cancel out. We write what's left over. What's left over is 2 as a lead 2 ion. 2 iodide ions makes lead 2 iodide. You know, a tip here is if you've done your work right, this reaction should also be balanced. And so as you look at this, we have 1 lead on both sides and 2 iodines on both sides. So that's good to go. Let's move on to number 2. Number 2 says iron 3 chloride and sodium hydroxide. These are both aqueous in the beginning, and we're going to run our reaction. So again, we're looking at what is the double replacement going to be. The iron is going to go with the hydroxide, so we're going to have iron 3s with hydroxides. How do I know that's an iron 3? Well, I was looking at those chlorides, and I know chlorides are -1, so means the iron must have been a +3. And then we're going to have a sodium ion that combines with chloride ions. It's going to make sodium chloride. So as we come over to this side, let's do that one first. The sodium ion combines with the chloride ion. Sodium's a +1 ion and chloride's a minus ion, so we're going to make sodium chloride. It's going to be just like that. And then our other compound is going to be the iron 3 with hydroxides. So iron has got a +3 charge. That means it's going to take 3 hydroxides to go with it, and that's what iron 3 hydroxide is going to look like. Okay. Next step we're going to do is we are going to balance this reaction by having probably a 3 in front of the sodium hydroxide and a 3 in front of the sodium chloride. Okay. Next thing we're going to do is we're going to look at these products here, and rule number 2 and rule number 3 both tell me that this compound should be aqueous. Sodium chloride is going to be aqueous. We have a lot of experience with salt, and we know that it dissolves in water as well. But then as we get to iron 3 hydroxide, rule number 7 says that salts containing blah 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 hydroxide are insoluble except when they contain ammonium or an alkali metal. Iron is not ammonium or an alkali metal. That means this is going to be a solid, and we're in for the long work again on this one. So we take everything that's aqueous and we write it as ion, starting with the iron 3 chloride. So that would be an iron 3 ion and 3 chlorides. The sodium hydroxides, there's 3 of them, so there's 3 sodiums and 3 hydroxides. The 3 sodium chlorides would be 3 sodiums and 3 chlorides. And then the iron 3 hydroxide, that's a solid, so we rewrite that. Those actually are stuck together, so we write them that way. Going through to remove my spectators, the 3 sodiums are on the left and the right. The 3 chlorides are on the left and on the right, so they cancel out, and when we write what's left over, what we have is an iron 3 ion reacts with 3 hydroxide ions to make iron 3 hydroxide, which looks like that. This is a solid. I don't know if I did that on the last one. We should be careful about always making sure we keep our state symbols on here. I'm trying to go fast to save some time on the video. So there's our answer for number 2. Let's move on to number 3. Number 3 says sodium nitrate and potassium phosphate. Sodium nitrate is aqueous and reacts with potassium phosphate, which is aqueous, to produce. Well, what does it produce? If we look at this, the sodium is going to go with the phosphate. Sodium is a +1 charged ion and phosphate is a -3 charged ion. Potassium is going to go with nitrate. Potassium is a +1 charged ion. Nitrate is a -1 charged ion. So if I make potassium nitrate over here, it's just going to be KNO3. And when I go and I make my sodium phosphate, it's going to take 3 sodiums to pair up with its 1 phosphate in order to make that compound like that. Next, I'm going to go in here and I'm going to balance this chemical reaction. So as I look at this, it looks like I need about 3 of the sodiums there, and I'm going to need 3 potassium. So I'm going to put a 3 over here too, and I think that'll do it. I think we're balanced at that point. Next step, we look at our solubility rules. Rule number 2 and rule number 5 tell me that potassium nitrate will be dissolved in aqueous. And rule number 2 and rule number 7 both tell me that the sodium phosphate is going to be aqueous. So, happy days! We have aqueous and aqueous, which means we bunched a bunch of aqueous compounds together, and they came out as a bunch of aqueous things. Nothing stuck to anything. This is no reaction, and we are done. Moving on to the last one, number 4. Number 4 says we are supposed to take silver nitrate and react it with barium chloride. When we do that, we're going to put the silver ion with the chloride ion. Silver is a +1 ion and chloride is a -1 ion. And then also the barium ion is going to go with the nitrate ion. Bariums are +2 ions and nitrates, Those are -1 ions. So when we write the products for this reaction, silver chloride is going to be 1 silver and 1 chlorine, because both are +1 and -1 charged. The 1 and 1 go together to make 0. And then when we make our barium nitrate, barium is a +2 ion, so it will take 2 nitrates. So I have to put that in parentheses. 2 nitrates to go with 1 barium. That's barium nitrate. Now, we look at our solubility rules. Silver chloride is rule number 3. All salts containing chloride are soluble except those with silver. That's going to be a solid, friends. And then barium and nitrate. So if we look at rule number 5, it says all salts containing nitrate are soluble. So that's going to be aqueous. Okay. Oh, we didn't balance it. Let's back up here. Got a little ahead of ourselves. Let's balance this thing. I think we're going to need 2 of those and 2 of those. Yeah, that looks pretty good. So now we're going to take everything that's aqueous, which consists of the initial things, the reactants, and then the barium nitrate. We need to separate those out. So 2 silver nitrates would be 2 silver ions and 2 nitrate ions. And then we've got a barium chloride, which would be a barium ion and 2 chloride ions. React to form 2 silver chlorides. We're going to leave those together because that's a solid. And then the barium nitrate is a barium ion and a nitrate ion. 2 nitrate ions because of the way that works out. Okay, so we're going to go in here and we're going to strike out our spectator ions, the barium and the nitrate, and write what's left over. It takes 2 silver ions and 2 chloride ions to make 2 silver chlorides. Hooray! And we are done with problem set 5.6. You're now going to get your aluminum chloride reaction sheet, and there's a lot more practice on that there.